Right, hello Year 13. So this is a C3 paper. This is January 2010. Okay. Right, so question 1, solve the equation e to the power of 2x minus 5 e to the x equals 0. Right, so the trick to this question is you need to spot this really is a quadratic in e to the x. So we've got e to the x squared minus 5 e to the x equals 0. So we need to factorise out e to the x in the same way you'd factorise x squared minus 5x. So it should look like this: e to the x times by e to the x minus 5 equals 0. And then just like if it was a quadratic, you'd make this equal 0 or this equals 0. So either e to the x equals 0, which hopefully you spot can't exist. So there's no power you can put any positive number at 2 to give 0. So that gives us no solutions. You might just want to write in your exam, no solutions. This one though, we've got e to the x equals 5. So to find x, we'd have to find the natural logarithm of 5. So you can either leave it like that, or you could call that 1.6123 significant figures. Alright, so you get a mark for factorising it. What's that? So factoring out e to the x or dividing e to the x. So it looks like you get 2 marks for that. 1 mark for e to the x equals 5 and another mark for ln 5. Alright, I always think it's best to leave an exact answer there, then you can't get tripped up with anything to do with significant figures. So here they say 1.61 or better. Okay, so question 2. The temperature big T, capital T, Celsius of water in a glass T minutes after boiling is modelled by the equation T equals blah blah blah, where B and K are constants. So this is some exponential equation. Initially the temperature is 100 degrees C and after 5 minutes temperature is 60 degrees C. So let's think what this means. Initially, in these questions, always mean T is, or little t in this case, time is 0. We know big T is 100. And then we know when T is 5, that big T is 60. So find B and K. So basically we're going to have to sub these into this equation and see if that will help us find B and K. So to start, let's sub in the first set of values. So we know when big T is 100, little t is 0. So plus BE to the power of minus K times 0. So you need to spot them. Well, if this is 0, then the whole thing will just be 1 because e to the power of 0 is 1. So 100 equals 20 plus B. So B is 80. Okay. So now that we know B is 80, we can sub in the second lot of points. So we know 60, so that's for big T, equals 20 plus 80, because we know B is 80 now, e to the minus 5k. Little t is 5, so this is to the minus 5k. So to solve this, first of all, let's try and get this e to the minus 5k on its own. So we've got to take away 20 to give us 40, and then divide by 80. So that's a half. So e to the minus 5k equals a half. And then we ln both sides to get this minus 5k on its own. So that gives us minus 5k, and then we get ln of a half here, which also is minus ln 2. The reason is ln to the half, ln of a half even, is ln of 2 to the power of minus 1, and then the minus 1 drops to the bottom, so you get minus ln 2, which just gives us a nicer answer here. So we can change the signs of both sides. We can say 5k is ln 2, so k is ln 2 over 5, and again we've got a nice whole answer there. So ln 2 over 5, again if you want to do significant figures, is 0.139. But let's use ln 2 over 5 because that's a lovely exact answer. Minus 80. Right. Find at what time, the temperature reaches 50 degrees C. So if that to happen, so big T is 50, and this is going to be 20 plus 80 e to the minus ln t over 5t. Alright, so you're more than welcome to use 0.138 or whatever here, if you like. So, similar to before, we're going to have to first of all get this bit on its own and then learn it. So, 50 take away 20 is 30, so 30 over 80 is 3/8, is going to equal e to the minus ln 2 over 5 t. So I'm going to learn both sides. So I've got a ln of 3/8 here, and then this is going to become minus ln 2 over 5t. So now in my calculator, I'm going to do this divided by this. So I'm going to make a fraction and do ln of 3/8 divided by minus ln 2 over 5. So I've got a fraction in a fraction on my calculator, which gives me 7.08 minutes. Try and think, does that sound right? If it was 60 degrees after 5 minutes, then 50 degrees after 7 minutes sounds okay. So, what have they got here? So they got the ln 2 over 5, and then 7.075 minutes. Any answers in the range 7 to 7.1 we'll accept. Alright, question 3. Right, given that y equals the cube root of 1 plus 3x squared, use the chain rule to find dy by dx in terms of x. So I'm just going to rewrite y as 1 plus 3x squared to the power of a third. And then if we differentiate that, so the inside function is 1 plus 3x squared, the outside function is to the power of a third. So we've got to think what happens to something to the power of a third? Well, it becomes a third times something to the power of minus 2/3. So x to the third becomes a third x to the minus 2/3. And then the thing we've ignored, we've got to times by the derivative of that. So the derivative of this, the 1 disappears, is 6x. So we can tidy it up a bit. A third times 6x is 2x. Then it's going to be 1 plus 3x squared to the power of minus 2/3. Right, given that, y cubed equals 1 plus 3x squared, use implicit differentiation to find dy and dx in terms of x and y. Show that this result is equivalent to the result in part 1. Okay. Right, that sounds very difficult to me. So let's first of all forget part 1 and do implicit differentiation. So to do that, we are using the chain rule again, so y cubed will become 3y squared, but we've got to times by the derivative of y, so the thing we've ignored. And then 1 plus 3x squared becomes 6x, just like before. Okay, so to get dy by dx on its own, we've just got to divide by 3y squared, which is, so 6x over 3y squared, the 6 and the 3 will cancel out to 2x over y squared, which is a much nicer expression. Right, now the horrible bit, we want to show these two things are equivalent. Alright, so it's up to you which side you work from. I would say, given that we know y is the cube root of 1 plus 3x squared, let's sub that into here. So we've got 2x over, so this is 1 plus, sorry, it's a cube root of 3x squared, isn't it? So this is the cube root of 1 plus 3x squared. So that's the same as y. Now if you look here, we've got the cube root squared, which is the same as putting something to the power of 2/3. So this is 1 plus 3x squared to the power of 2/3, which you'll see is equivalent to this up here. So this is to the minus 2/3, which means it's 1 over. Okay. So there's lots of different ways of going about that. Ours probably looks different to the mark scheme, which is, so they've got the same thing there. You get a minus 3 into 6x over 3y squared and cancelling down, and they have done similar to what we've done. So they've subbed in y, shown it's the power of 2/3, and then I would explicitly write this minus 2/3 bit. Okay. Right, question 4, so we've got a couple of integrals. Look very similar, but you notice there's different numbers of marks here. So evaluate the following intervals, giving your answer in exact form. So if we look at this one, you need to spot that the top of that is the derivative of that. So if you get a fraction where you've got some denominator where the numerator is that differentiated, then you know the answer is going to be ln of the denominator, so x squared plus 1 in this case. Now I should put modular signs here when I'm integrating, but because I know x squared plus 1 is always positive, because x squared is always at least 0, I'm adding 1, I'm not going to bother. So this is going to be ln of 1 squared plus 1, which is ln 2, minus ln of 0 squared plus 1, which is ln 1, which is 0. So the final answer is ln 2. Right, this one looks a lot more difficult to me, especially because it's 5 marks. So I think we've got to do some kind of substitution here. So if we differentiate this, we don't get the top. So my gut says we've got to substitute in x plus 1. So the reason being that if we think about the thing you sub in is going to be where you've got a function of a function. So x plus 1 is a function, and it being over 2x is the kind of compound function. So I'd say u equals x plus 1, which means du by dx is 1. Now that's nice because it means just that du equals, if I can write, dx. So we can swap that out. Okay, so let's take out the x plus 1 and put in a u. Let's take out dx and put du. And at the point where you swap dx and du, you need to change the limits. So our u limits are our x limits plus 1. So we just use the same substitution we made. So 1 plus 1 is 2, 0 plus 1 is 1. Problem here is that we've still got an x. So what we need to do is look back at our substitution and make x the subject, and then we can sub that in. So between 2 and 1, we've got 2 lots of u minus 1 over u du. Still not a very nice integral, but it's something we can work with. Alright, so what we need to do now is split this up into 2 fractions. So if we imagine expanding the top, we get 2u minus 2. So as 2 fractions, this will be 2u over u minus 2 over u du. I'm saying u too many times. Okay, so now we actually need to integrate this. So 2u over u is just 2. So let's write it out again actually. So it's 2 minus 2 over u du. So 2 integrated is 2u. Minus 2 over u integrated is minus 2 ln u. So we're doing that between 2 and 1. So we've got to sub in each part. So if we sub in 2, we get 2 times 2, which is 4, minus 2 ln 2, minus, if we sub in 1, 2 times 1 is 2, minus 2 ln 1. Now ln 1 is 0, so we can forget about that. So this all simplifies down to 2 minus 2 ln 2. Right, I've probably said 2 about 100 times in the last minute. Okay. Question 5. In curves part 1, part 2 of equations, y equals a plus b sine cx. Let's think about what that means. So a will shift it up and down. B will change how much it's been stretched by. It's almost like the amplitude if you're a physics student. And C will be how much it's stretched parallel to the x-axis, or is it the period or wavelength if you're a physics student. So A, B and C are constants for each curve. Find the values of A, B and C. So looking at this first one, so if you remember our sine curve, it goes between 1 and minus 1, and it's one wave takes 2 pi radians. Okay, so if we look here, it's going between 3 and minus 3, which means this B must be 3, so it's been stretched by that much. It hasn't been moved up or down at all, so A will be 0. So let's say A equals 0. B will be 3, as I just said, and C is to do with how much it's stretched. Now, if we look here, this, instead of doing a whole wave from 0 to 2 pi, this is doing it from 0 to pi. So it actually fit two waves in, sorry about that, in the same space as one wave before. So it's, if you like, it's been squashed in. So you can think of it as a stretch of scale factor of half, which would mean C is 2. Okay, if you don't understand that, I'd recommend revising transformations. Right, this next one looks a bit trickier. So first of all, it looks the wrong way up to me. So it's going between 0 and 2, so I don't think it's been stretched at all, because it's still oscillating between 1 and minus 1. Right. So, what is A plus B sine x, sine cx? Right, so I think it's been flipped, but it hasn't been stretched, which means B will be minus 1. So it's been, if it was just flipped though, it would be still between 1 and minus 1, so it must have been shifted up, which means A would be 2. And then if we think about we need to think about whether it has been stretched or not horizontally. So if we look, it's going from 0 to, not from 0, so it's going round its first quarter of the quadrant in a half pi. So it means it'll be here by pi, here by 3 pi over 2, and here by 2 pi. So it actually still does one wave in 2 pi radians. So that C will be 1, it won't affect it. So let's double check that. So we need 0, 3, 2, is that what we got? Yep. And then we also had A is 2. I meant to write A as 1 there. I don't know what I'm talking about. So it's moved up 1. And then, so 1 minus 1, 1, or 1, 1 minus 1, apparently. Okay. Because it could have been flipped in the y-axis as well. Right, question 6. Write down the conditions for f of x to be an odd function. So if f of x is an odd function, that means f of minus x equals minus f of x. For g of x to be an even function, that means g of minus x equals g of x. You need to know that by heart. So basically it means an odd function, if you reflect it in the y, it's the same as reflecting in the x. Even if you reflect it in the y, it stays the same. Hence prove that if f of x is odd and g of x is even, g of f of x is even. Right, so let's think about g of f of x. Now if we want to show that this is even, then we need to start with g of f of minus x and get to just g of f of x, just like this definition here. So let's see what we can do. So g of f of minus x, so f of minus x, as f is odd, this is going to be the same as minus f of x. So I haven't touched g, I've just swapped out minus, which I'm allowed to do because f is odd. And now g is even, so if you've got g of minus something, that just equals g of that something. So that equals g of f of x. So if you look, we've started with g of f of minus x, and we've done some maths and come up with g of f of x. So we've proved that it will be even. You probably would write a statement after any proof. So you get a mark for both of these each. You get a mark for this first step and a mark for getting to that, and you do need to sum up so gf is even. Right, question 7. Given that arc sine x equals arc cos y, prove that x squared plus y squared equals 1. Hint, let arc sine x equals theta. Now when they give you a hint, I would definitely take their hint. So arc sine x equals theta, so that would mean theta equals arc cos y, which should mean, you probably would never see in there, so that's like cos to the minus 1 of y, which would mean y is cos theta. And we also know from this that x would be sine theta. So if we look what we've got here, cos and theta, x and y. So we know sine squared theta plus cos squared theta is 1. And given we've shown those are x and y, this is the same as saying x squared plus y squared equals 1. So let's look at the mark scheme. So you get a mark saying x is sine theta, mark saying y is cos theta, and a mark for then subbing it into x squared plus y squared. Yeah, that's a really horrible question. Right, question 8. Figure 8 shows part of the curve y equals x cos 3x. The curve crosses at O, P and Q. Find the exact coordinates of P and Q. So if we look at P and Q, that is going to be where the curve x cos 3x equals 0. So either x equals 0 or cos 3x equals 0. So x equals 0 is this point here, O. So if we think of all the solutions to this, there's actually going to be infinite of them, but I think the first two are going to give us p and q. We can imagine this curve carrying on and kind of looking like cos but being stretched out. So cos to the minus 1 of 0, so think when does cos equal 0 on our graph? So the first time is at like 90 degrees, or in this case pi over 2 radians, and then the next one would be at 270 degrees, or 3 pi over 2 radians, and then it would carry on in that pattern. But we only want the first two, so this is going to be, x is going to be pi over 2 divided by 3, which is pi over 6, and q is going to be 3 pi over 2 divided by 3, which is pi over 2, and write them as coordinates, so make sure you say that's pi over 6, 0, pi over 2, 0. Right, find the exact gradient of the curve at the point P. So the first thing we're going to have to do is differentiate x cos 3x. So hopefully you spot, well, we're going to have to use the product rule. So u is x, v is cos 3x, so du by dx, which I'm going to write as u dash, is 1, and differentiating cos 3x, so v dash, is going to be minus 3 sine 3x using the chain rule. So v times u dash is cos 3x plus v times u dash, as I just said, isn't it? So basically, one function times the other derivative plus the other function times that derivative. So we're going to have this times by x, so minus 3x sine 3x. And they wanted to know the gradient at P. So at P, x is pi over 6, so we need to do cos of 3 pi over 6 minus 3, and then I'm going to sub in a pi over 6 here, sine of 3 lots of pi over 6. Alright, so this is cos of pi over 2, which is 0. You can put that in your calculator. Minus, this cancels down to pi over 2. And this is sine of pi over 2, which is 1. Again, you can put that in your calculator. So the gradient is minus pi over 2, which looks about right. Let's double check. Yeah, minus pi over 2. Right, but that wasn't the whole question. They also said, show also that the turning points of the curve occur where this equals a third. So x tan of 3x is a third. Right, so we know the turning points occur when the first derivative is 0. So if this equals 0, it looks like we need to show x tan of 3x equals a third. So I think we've got to do sine of 3x divided by cos of 3x at some point. So let's split them 1 onto each side. So cos of 3x equals 3x sine 3x. And then to get my tan, I'm going to divide by cos now. So I'm going to get 1 equals 3x tan 3x. And then if I divide by 3, we get to what they've got there. So that's quite a lot, but it's not bad for 7 marks, I don't think. Right, finally, find the area of the region enclosed by the curve and the x-axis between O and P. So we're looking for this area here, giving your answer in exact form. Okay. So we need to integrate our function, which was not a nice function, x cos of 3x, between 0 and pi over 6. So I think the reason this is like 6 marks or whatever is because we need to do integration by parts. The reason being x isn't the derivative of this. If it was, we could do, what's it called, substitution. So in this case, we need to decide which one's going to be v and which one's going to be u dash. So you want to end up with something nice to integrate as the second term. Okay, if you haven't revised integration by parts, this might make no sense to you. So I'm going to make x be u, and I'm going to make cos 3x be v dash. So u dash will be 1, and v will be a third sine 3x. Okay, you should be able to integrate that by inspection. So here we're going to have uv, so this is going to be x times by a third sine 3x, so x over 3 sine 3x between pi over 6 and 0, minus the integral of v du, so these two things times together, so that's a third sine 3x. I'm going to take that third outside, and again it's being between 0 and pi over 6. Right, I think we've earned the majority of our marks with that line of working. So let's work this bit out while we're here. So if we sub in pi over 6 to this, that's going to be pi over 6 divided by 3 is 12. So pi over 12. No, it's not. It's pi over 18. Sine of 3 pi over x. You can put down your calculator. That'll give you 1. So it does nothing to that. When we sub in 0, this whole term will be 0. So this whole bracket here becomes pi over 18. Right, sine of 3x will become minus a third cos 3x, I want to say. Yeah. So let's sub in pi over 6 and 0. Sorry about my voice. So if we sub in pi over 6, this will be cos of pi over 2, so the whole thing will be 0. So we just need to take away what we get when we sub in 0. So because we're taking it away, this minus will become a plus, and it's going to be a third there, I want to say, because cos of 0 is 1. So I want to say, when we simplify all that, we get pi over 3 minus a ninth. That plus is really confusing. Pi over 18 minus a ninth. Okay, lots of room for stupid mistakes there, especially when you're doing all this subbing in. You're very welcome to use a calculator. Okay. No, I managed to avoid any mistakes. So you get a mark for correct integral and limits, so setting that up. A mark for kind of deciding which things are going to be by parts and stuff. A mark for this part, so your uv and what you're integrating can be about limits. Mark for then, so they've brought it all into one thing, which will make more sense, make it a bit easier. And then steps getting towards pi over 18 minus a ninth. Okay, question 9. Figure 9 shows the curve y equals f of x. F of x is this monstrosity for the domain 0 to 2. Okay. Part 1, show that the derivative of f of x is this, and hence that f of x is an increasing function of x greater than 0. Okay, so we need to show it's an increasing function. Alright, so we can forget about the diagram for now and just think about differentiating this. So hopefully you spot, if we're differentiating, this is going to be the quotient rule. So this is u, this is v. So u dash is 4x, v dash is 2x. So we've got to do v du minus u dv over v squared, and it has to be in that order. So v du is 4x, x squared plus 1. U dv is minus 2x, 2x squared minus 1. Let's double check that. Good. You can see here again, room for error, over x squared plus 1, all squared. So let's see if we can sort out the top, make it look a bit nicer. So we've got 4x cubed plus 4x minus 4x cubed, that's nice, minus 2x plus 2x, two minuses. So those two cancel, so it's still all over x squared plus 1 squared. So we get 6x over x squared plus 1 all squared. Okay, so we want to show it's an increasing function. So when is it an increasing function? Well, that'll be when this is greater than 0. So for this to be greater than 0, we can times by the denominator, which is nice because it gets rid of it, which would just mean that 6x is greater than 0. which would mean dividing by 6 just means x has to be greater than 0. So what we've shown is if the derivative is positive, in other words it's increasing, then we've done some maths and shown, well, that means x must be positive. Okay. Very good. Right, so that's part 1. I'm assuming there's part 2 somewhere. Right, find the range of f of x. So the range is all the y values it can take. So from our diagram, we can see the minimum point will be when x is minus 1. Sorry, the minimum point is minus 1, so we know f of x, the bottom will be minus 1, and the highest point, we've got to sub in x equals to 2 into the original function. So I'm going to put x equals 2 into here. So 2 times 2 squared minus 1 over 2 squared plus 1, and that gives me 7/5. So that highest point occurs at 7/5. So the range is minus 1 up to 7/5, or 1.4 if you prefer decimals. I'm just going to double check those. Yep, oh, they've even got a mixed number there. Good. Right, so we're on the right tracks. Right, given that, bold, we don't need to work this out. Given that the second derivative is this, find the maximum value of f dash of x. Okay, so not the maximum value of f of x, the maximum value of the derivative. So our derivative was 6x over x squared plus 1 all squared. So if we're finding the maximum value of f dash of x, we need to differentiate it and set that to 0. So if we differentiate this, we're told we get this. So what we're going to have to do is work out when does this equal 0. Now if you're working out when a fraction equals 0, that means that the numerator has to equal 0. Okay, so if we try and solve this, we get 18x squared, don't know why I'm writing this order, equals 6. So x squared is 6 over 18, which is a third. So x will equal plus or minus this square rooted, so 1 over root 3. Now, the function's only defined between 0 and 2, so this maximum value must just be 1 over root 3, so we can forget about the minus. So I believe the answer is 1 over root 3, which really we should say is root 3 over 3 if we rationalise the denominator. Now, I think really, if we wanted to check that was a maximum, we'd have to find the third derivative and show that, but I believe as we've got the graph, we can justify from the graph this must be a maximum and not a minimum. As we can see from there, it's always, in fact we showed it's always got a positive gradient. So let's see what we've got to do. So a mark for setting it to 0, a mark for getting 1 over root 3, and we didn't actually answer the question. So they asked us to find the maximum value of. We found where it occurs, we need to sub it into here. Okay, so I'm going to put 1 over root 3 in my calculator, then do 6 times the answer over answer squared plus 1 squared. And that gives me 9 root 3 over 8 when you sub it in here, and you can leave that as 1.95 if you want. Again, this is an exact answer, so I prefer it. Right. So soldiering on. The function g of x is the inverse of f of x. Write down the domain and range of g of x. Right, the reason we can just write this down is because as it's the inverse, we just have to swap the domain and range of f of x. So the domain of g of x is going to be between minus 1 and 1.4, so it's the range of the other one. The range of g of x is going to be the domain of our original function, so between 0 and 2. Right, add a sketch of the curve of y equals g of x to the copy of figure 9. So you need to know that if you find the inverse function, it's going to be a reflection in y equals x. So I would draw a y equals x on there for yourself, and then think about what it would look like. So we know it's going to start from here. It's quite difficult. I'd definitely do it in pencil to start with. So it kind of curves around like that. I'm just trying to draw a reflection, and then looks like this. So we know it's going from -1 to 1.4 here, and from 0 to 2 here, so it needs to look something like that. Let's look at the mark scheme, see how mean they are about it. So, domain and range, you get a mark for each, and then, so reasonable reflection in y equals x, and then you need to make sure you're doing it at the right domain and range, that's what the second mark's for there. Right, and there is yet more. Show that g of x equals this. So we need to actually find the inverse function. So starting with, let's go back to here. This question. So the way we find an inverse function, we say this is y equals 2x squared minus 1 over x squared plus 1. And then we have to swap around x and y. So if this is the function, our inverse function will be x equals 2y squared minus 1 over y squared plus 1. And now we need to make y the subject. Okay. So my goal is going to first of all be to make y squared the subject, and then I can square root it. So this is a bit like a change in the subject question from GCSE. There's nothing much more scary. It's just that you've had to know to do this to start with. So I'm going to times by the denominator. That's how I get this left-hand side. Then I'm going to get all the stuff with a y onto the left. So I've got xy squared minus 2y squared, and everything else on the right. So I've got minus 1 minus x. Then I'm going to factorise out y squared. So in the brackets I'll have x minus 2, and that will equal minus 1 minus x. So now divide by y squared, so I get minus 1 minus x over x minus 2. And then I'm just going to double check what the answer looks like, because mine looks a bit dodgy. So can you see we've got minus 1 minus x, they've got x plus 1, we had x minus 2, they've got 2 minus x. All we have to do is times our numerator and denominator by minus 1 to effectively switch all the signs round. So there's nothing wrong with ours, but it's just they don't want it to look like that. So this would become minus x plus 2, which you can write as 2 minus x. And then if we square root, we get y equals, and I'm going to write g of x, because that's what it is now, the square root of 1 plus x over 2 minus x. Alright, and that's the end of that very long question, and the end of the paper. Okay, so I hope you found that useful. I apologise for any mistakes. Any criticism or requests would be much appreciated. Cheers.